Hey guys, today we are going to be talking about ionic bonds. We've talked about a little bit of them, but I wanted to just go ahead and we're actually just going to do the first two pages of Chapter 5, Section 2. It is on page 158 and 159. Because I feel like this chapter or this section has a lot of information that I think that you need to we need to go slowly with. So, first things first, let's go ahead. We started today talking about ions. Many times, groups of atoms, they strive to achieve the same configuration as the noble gases. And when I'm talking about configuration, I'm talking about they want to have their outer shell full, okay? So in order for them to do that, they either have to lose or share or receive electrons to make them more stable. So losing or gaining electrons, what happens is it results in the formation of an ion. An ion is any type of element that is positively or negatively charged, okay? So we know that an electron has a charge of -1, okay? We know that a proton has a positive charge of 1, okay? So overall, if you have the same amount of protons and the same amount of electrons, you have an element that is neutrally charged. It doesn't have a charge at all, okay? So, elements in group, so let me go ahead and discuss this and give you some examples. An ion, okay, when an atom loses an electron, it loses that electron. So it's losing that negative charge, right? So because it loses that negative charge, it becomes a positively charged atom, right? However, when it gains an electron, that electron is negative, okay? And it has more negative than it does protons. So when it gains that negatively charged electron, it becomes a negatively charged atom. Okay? Some atoms are, they're made up of several atoms. So, for example, when you have pneumonia, you have an ion that is made up of nitrogen and hydrogen. Those are called polyatomic ions. It's not just one, it's two. So, poly meaning more than two. Just like mono means one, poly means two. Monotheism, the belief in one God. Polytheism, the belief in many gods. So, just know that there are some types of ions that have a polyatomic ion. Polyatomic ions, meaning more than one element is chemically combined together. Like most ions, the polyatomic ions, they also have a positive or negative charge. Okay. So, oh, and also here's a quick tip for you. Anytime you guys are doing crossword puzzles, they like to use the answers to the crossword puzzles. They like to use like a positively charged atom. It's always ion, I-O-N. Just an FYI. Okay, so let's go ahead and talk about losing and gaining electrons. Okay, so you know the alkali metals, they all have one valence electron. And so they want to achieve that noble gas configuration. They want to have that full outer shell, and they want to lose that one electron. So they're going to lose it. So, for example, let's consider potassium like we did earlier. Potassium's atomic number is 19. And remember that the atomic number tells us the number of protons and the number of electrons when it is stable. So you have the same number of protons that you do electrons. However, to make it an ion, we are actually going to, and because it wants to be a noble gas, because it's in group 1, they're going to lose that, it's going to react, and it's going to lose that electron. So it has, so when it loses that electron, it becomes positively charged. So you have, let me show you this picture. So you have potassium. I don't know if you can see it very well. It loses an electron. Sorry. So then because it loses an electron, it becomes a potassium positive, a positive electron. I don't know if you can see it very well because it's all, okay? Let's see if I can, here we go. So, which has the same electron configuration as argon. How did that happen? Well, let me go ahead and explain that to you. Because it lost that electron, it now has how many electrons? What's 19 minus 1? 18, right? So if you look at the periodic table and you look at your in your agenda, okay, and you look at, remember, the atomic number tells the number of protons and electrons in a stable atom. So potassium has 19, it loses an electron, so it has the same electron, making it 18, so it has the same electron configuration as argon, as one of the noble gases. So that's how you do that. Now let's do another one. Okay, so atoms in groups 1, 2, and 3 tend to lose their outer electrons and form cations. All your metals, because they're transferring those electrons, become cations. C-A-T-I-O-N-S. Okay? So, for example, a magnesium atom, the symbol is Mg. It's in group 2, so column 2. It loses 2 valence electrons, 2 of them, okay, and forms, and because it lost those electrons, it becomes 2 positive, right? Because it loses those 2 electrons, so you have those 2 positive protons that are still out there. So this is what it looks like. You have magnesium. It loses 2 electrons, and now it becomes magnesium, and that's actually a 2. 2 plus. Okay? So we know magnesium has an atomic number of 12, right? And that atomic number tells us the amount of protons and electrons. So, what's 12 minus 2? 10, right? So, 10. So it has the same configuration as what element? You are going to tell me that element on your do now tomorrow. And we're going to see if you understand how to do that. I think you got it. You need to just use your periodic table. But basically, magnesium loses 2 valence electrons, making it have the same configuration as what element? Okay? Alright, let's move on. Okay, so we've talked about groups 1, 2, and 3. We've talked about losing electrons. Now we're going to talk about gaining those electrons. Because your nonmetals, they want to gain those electrons because they have an almost complete outer shell. So groups 5, 6, 7, and 7, not 8. They tend to gain electrons and form anions. A-N-I-O-N-S. Anions. So let's consider chlorine. Okay? Chlorine already has 7 valence electrons. So how many more electrons does it need to become stable? How many more? If you guys said 1, then you're correct. It only needs 1 valence electron. So rather than losing all 7 of the electrons, those valence electrons, it's going to gain 1 electron to form chlorine negative. Okay? When it gains an electron, if you look at chlorine, the atomic number, remember, atomic number tells you what? It tells you the protons and electrons in a stable element or atom, or the stable atom. So chlorine has an atomic number of 17. So chlorine, in order to make it a negative chlorine atom, because it's gaining that negative charge, that negative electron, it's gaining that electron, it's going to make it have the same electron configuration as argon. If that's what you said, you were right. Okay, so what we're going to do tomorrow, I think that this pretty much sums up most of our information. I am going to have you fill out some more of your foldable. Ionic bonds, they hold it's an electrostatic force, and we're going to talk about those, but your metals are cations because they give up or lose. They're always positively charged, whereas your nonmetals are anions, and we're actually going to talk about this tomorrow, and I'll have you fill that out. Tomorrow we're also going to identify the ion that's going to be likely formed by the following elements. We're going to do calcium, nitrogen, rubidium, barium, chlorine, aluminum, let's see, cesium, and selenium. So we're going to do all those, and we're going to actually talk about the symbol or formula, the symbols and formulas of those elements, and the ion that's going to likely, if it's going to be a positively charged ion or a negatively charged ion, that's what we're going to talk about. So I'm going to end for the night. I'm going to finally go home. I hope you don't forget, I want to know what that element was in that configuration. If you need to rewind this video and go look at it, then I suggest you do. And we'll talk to you later, and have a great, great evening.